Put on the group also. I can share it on the group. Has nobody done? Okay, we are starting the network. We noticed it was not very bright, it was blurred, so we had to restart the live. So please do well to join. Do well to join. Do we have first people now?
No, no.
Some of them are not aware of it. Have you posted it?
Yeah.
Share it. Go on YouTube, then share it to them. Not from me. If you can share from there. No.
No.
Hmm? No, no, click. No, no, no.
I've checked it now.
I want to know about it. Is it? I'm feeling whether it's you that is showing one person.
No, no. They are coming up.
Okay, please, welcome. Do share this link to others. Sorry for the inconveniences. Sorry for the cuts. Share it. Tell others that we have reconnected. Tell others we have reconnected. Please, so that we can move on. So inform others. Share it. Those people that were present, I think they should just check my page. Go to live. You'll see live. Click live. Then you'll see this link. You can join from there. So how many persons now?
8.
8. All right. So let me wait for 10 persons. I think I gave a question. We're looking at rotation of plane mirrors. So let me just quickly repeat it. We said that if a plane mirror is rotated through an angle theta, that the angle of reflection, the new angle of reflection, will turn through twice that angle. That is what you have on the board. A plane mirror is rotated through an angle theta, then the new angle of reflection would rotate through twice that angle. And I gave a question. I said, if a plane mirror is rotated through an angle of 45 degrees, through how many degrees will the angle of reflection turn? Drop the answer in the comments quickly. A plane degrees will the angle of reflection rotate? Okay. Who has the answer?
Anthony said 90.
Anthony, thank you.
Chisom 90.
Chisom 90.
And Innocent 90.
Innocent 90. That is correct. Yes. So the angle of reflection would be 2 theta, which is 2 times 45, which is 90 degrees. So quickly, we want to get to the next point. Now, do well to like this video. This is a new one, so like. How many persons are there now?
10.
10. So 10 of you should like and also share the link with your friends. Now, we want to look at number of images formed by 2 plane mirrors. So if two plane mirrors are inclined at an angle theta. So if you incline 2 plane mirrors, say you have one mirror like this and you have another one like this. These are 2 plane mirrors and they are inclined at an angle of theta. How many images would be formed by this plane mirror? Just like you go to the barbing salon to cut your hair, you notice that they usually have a mirror behind you and they have a mirror in front of you. So if you look at the one in front of you, you'll be seeing so many images of yourself formed there. That is what we mean by inclination of plane mirrors. In the case of the barbing salon, the 2 plane mirrors you have are parallel to each other. So it means that their angle of inclination is 0 degree. Now, if the angle of inclination is theta, which could be 0, 90, any value, how many images can be formed The number of images that can be formed, n, is 360 over theta. Is 360 over theta, provided that n is odd. You use this formula provided that n is odd. So it means that the number of images should always be odd. If you use this formula, theta divided by 360 divided by theta, if you use this and you get even value, then you subtract 1 from it. Let me write it. If 360 by theta is even, then you subtract 1 from it. For example, pick one, you tell me the answer. Two plane mirrors are inclined at an angle of 30 degrees to each other. Two plane mirrors are inclined at an angle of 30 degrees. How many images would be formed? Quickly, tell me. Two plane mirrors inclined at an angle of 30 degrees to each other. How many images would be formed? Quickly. I'm waiting for your answers. Any answer yet?
Yes.
Right.
Jess said 11.
11.
Innocent agreed.
Okay.
John Paul said 12.
Okay.
Other Chike said 11. Chima said 9.
Chima 9.
Chidubem 11.
Okay.
Zebulun 11.
Okay.
Ruth 11.
Ruth 11.
Chukwuebuka 11.
Chukwuebuka 11. Thank you. Now let's verify the answer. Now the angle of inclination theta is 30 degrees. And we say to find the number of images, we use 360 over theta. So we have 360 divided by 30. So if you solve this, you will get 12. Now I said provided that n is odd. That is when you stop. If you notice 12 is even. So it means this would not be my answer. The number of images should always be odd. If you get even, you subtract 1 from it. So it means that my final answer is going to be 12 minus 1, which is 11. So 11, those that said 11, you are very correct. Now, very quickly, I want to move to curved mirrors, which is too important for anybody to miss. How many persons are there now?
17.
17. Tell others to join. I want to get to curved mirrors. Too important. I don't want anybody to miss this fact. Curved mirrors. Invite your friends. Like the video. How many likes do you have?
4.
My God, 4 likes for 17 people. If you have not liked the video, please hit the like button. Please hit the like button. Thank you for supporting. Hit the like button. Hit the like button, please. And you are yet to subscribe, please just subscribe. It does not remove anything from your data. The same data, just to support and show YouTube that the channel is actually growing. So support, like, how many?
7.
7. Please like if you are there. Just click like, please. Just very fast. And subscribe if you are yet to do that. So we want to look at curved mirror. Curved mirror. Now, remember, I'm doing a summary. I'm doing a revision class, a summary. So I won't go into much details. But we have 2 major types of curved mirrors, right? Yes. Number 1 is concave mirror. Number 1 is concave mirror. What is a concave mirror? A concave mirror is one in which the inner part is the reflecting surface and the outer part is the coated part. I repeat, a concave mirror is one in which the inner part is the reflecting surface and the exterior is the shaded part. So this is your concave mirror. So it means that this is the back of our mirror and this is the front of our mirror. This is the way I will be drawing it henceforth, but you can still draw your concave mirror like this. You can still draw it this way. In this case, this would become the back. This would become the front, but I choose the first one, right? For the sake of us, the sign convention we'll be learning very soon. So I choose the front, the first one. So this is a concave mirror. Now, what is the second type of curved mirror? Number 2 is your convex mirror. Convex mirror. Now, what is convex mirror? Convex mirror is a mirror in which the inner part is the back of the mirror and the exterior part is the reflecting surface. This is what I mean. This is it. So this is the back, and then this is the what? Front. Now, the pattern you would have noticed I'm choosing, I always make the front of my mirror to be on the left-hand side. So this is my left. So I always like the front of my mirror to be at the left. So you can notice in this also, the front of my mirror is also at my left-hand side. So this is the pattern I choose, even though this is also correct. This is also correct. In this case, this is the back. This is the front. But I choose this and I choose this. So follow me and you'll see the reason why I've chosen these two for easy remembrance of sign convention when we're doing calculation. So if you are following me, then we want to move on. So these are the two types of curved mirrors that we have. We have another one, which I would mention at the end, which is parabolic mirror. I will mention it at the end, and I will explain the importance of your parabolic mirror. Now we have the concave and the convex mirror. Now, before we dive deep into this thing, we want to look at the terms that are used. Please take note, like I said, every single thing I'm explaining here is important for the sake of your exam. Exam can ask you definition of these terms. That this represents which of these. You see this, that, right? Now, quickly, terms. Number one is pole. What is the pole of a mirror? The pole of a mirror is the geometrical center of the mirror. That is pole, the geometrical center of the mirror. When we say geometrical, if I have this marker, what is the geometrical center of this marker? It's somewhere in between. The exact center of this marker is what you refer to as the geometrical center of this marker. So if I have a mirror like this point, which is the center, is the pole of my mirror. So that is one. Number two thing I want you to know is what you call your center of curvature. What is center of curvature? Let me write it. Number two is center of curvature. Center of curvature is the center of the sphere from which the mirror is cut out. Center of curvature is the center of the sphere. Remember, these mirrors we are considering, the concave mirror and the convex mirror, both of them are called spherical mirrors. So you should take note of that. Both of them are referred to as spherical mirrors because both of them are brought out from spherical surfaces. So the center of curvature is the center of the sphere from which the mirror is cut out. So you have a sphere like this, and then the center of this sphere is this. If you cut out a portion of this to become your mirror, something like this, let me erase the other part. So since this part is what I want, I can cut it and remove these other parts, right? Now, this particular center, which is the center of the whole sphere from which the mirror is cut, this is what you call center of curvature. It's different from pole. Pole is located at the mirror, but center of curvature is not around the mirror, it's just within the center of that sphere. So that is center of curvature. And the next I want to mention is principal or major axis. Principal or major axis. What is the principal axis? The principal axis is a line that connects the center of curvature to the pole of the mirror. Now, this is my center of curvature, which is denoted with C. This is the pole of my mirror, which is denoted with P. The principal axis is a line that joins your center of curvature to the pole of a mirror. So if I join this with a line, this line is what you know as principal axis. Very quickly, number four. Number four is what we call the radius of curvature. Radius of curvature. Of radius of curvature, it quickly tells you that both of them are not the same. So radius of curvature is the distance from center of curvature to pole. Center of curvature is just a point, it's not a distance. Center of curvature is a location, is a point, but radius of curvature is the distance. So when you decide to now measure this, from this point, you measure it to this point. That length is called the radius of curvature. But only this point is called the center of curvature. I believe it's clear. Number 5 is what we call the focal point. Focal point, which you can still call focus, right? Yes, the focal point or focus is a point along the principal axis. That is first thing you should know. It is a point, is not a distance. It is a point along the principal axis where light edge or appear to diverge from. I would repeat, the focal point is a point along the principal axis where light rays converge or appear to do what? Diverge from. That is focus or focal point, or you can say principal focus, anyone you call it. Now, if I draw this, say this is my mirror, and then this is my principal axis. This is my center of curvature. You notice if I put incident parallel rays on this mirror, if I incident parallel rays, when they hit my mirror, all of them would come and return to a point. They would come and return to a point. They would come and return to a point. This is what you call convergence. So this point where these rays converge is what you call your focal point. Focal point, you can see, is a point along your principal axis. So therefore, the next thing you want to know is that the focal point is located halfway between the center of curvature and the pole. The focal point is located halfway between the center of curvature and the pole. That is to say, if you locate your focal point at this point, it simply means that from here to here is equal to the distance from here to here. That is it. Then number 6 is what you call focal length. Is what you call focal length. Focal length is usually denoted with small letter f, but focal point is denoted with capital letter F. So what is focal length? Focal length is the distance from the pole of a mirror to the focus. Focal length is the distance from the pole of a mirror to the focus. Distance, that distance, this is our pole, this is our focal point. The distance, when you measure this distance, you call it focal length, right? Now, quickly, before we continue, I want you to know that for focal point, I'm not talking of focal length now. For focal point, you should know that the focal point of a concave mirror is real. The focal point of a concave mirror is what? Real. Take note of that. They can ask you in an exam which of the following is true. They will give you a combination of different statements. The focal point of a concave mirror is real. The reason why it is real is because the focal point is located in front of the mirror. If you draw a convex mirror, the focal point for a convex mirror is virtual. Take note of that. The focal point of a convex mirror is virtual. If we draw, this is our convex mirror, and this is the back of our convex mirror. This is where your focal point would be. This is where the focal point would be at the back of the mirror. And that is why we say the focal point of our convex mirror is virtual. But that of our concave mirror is real because it's always in front of the mirror. So take note of that. And the last term I want to mention, as number 7 term I want to mention, is what you call paraxial. Paraxial rays. Okay, I'll mention 2 terms. Paraxial rays. Why I will mention this is so that at the end, where we'll be talking about parabolic mirror, I'll still bring back this point. Now, what are paraxial rays? Paraxial rays are rays that are parallel to the principal axis but close to it. Paraxial rays are rays that are parallel and close to the principal axis. How many persons are there now?
20.
20. How many likes?
We have about 13 likes.
13. We still have some persons that are yet to like the video, so do well to like so that you don't forget. I know you are forgetting. Now, what are paraxial rays? Paraxial rays are rays that are parallel to the principal axis and also close to the principal axis. So if I draw something like this diagram you can see on the board. Now these ones, this one and this one that are closer to the principal axis, these two can be called paraxial rays. Number 8, which is the last, is marginal ray. Marginal rays. What are marginal rays? Marginal rays are rays that are parallel to the principal axis, but they are far from it. So these two extreme rays, they are marginal rays because they are parallel, but they are not close enough to the principal axis. So these are terms that you should know that are used in mirror. I'll quickly number them. I talked about pole, I talked about center of curvature, I talked about radius of curvature, I talked about focal point or focus, I talked about focal length, I talked about principal axis, I talked about paraxial ray, I talked about marginal ray, I talked about radius of curvature. So we mentioned all these things, which are very important for you to take note of. Now, very quickly, moving on, we understand what curved mirrors are, the concave and the convex mirror, and we have seen the terms that are associated with mirror. So very quickly, we want to see the rules that are associated, rules in image formation, Now, I'm not going to be drawing any diagram because it's a revision class, right? So I'll save you the stress of drawing. But why I want to mention these rules is because in my past question here, an exam year asked, one of the following is not a rule. That is why you should take note of it. So I'm teaching based on what I've studied from your past question. So any point I mention, don't neglect it. It's very important. So I want to look at rules for image formation. Now, when you want to determine, when you place object in front of a mirror, the image will be formed at a certain point. How do you determine where the image will be formed? You follow the rules. And these rules we want to mention, it is applicable to your concave and convex mirror. So both of them follow these rules, right? And we have 4 of them. So number 1 rule is that rays that are parallel to the principal axis would reflect through the focal point. Rays parallel to the principal axis would reflect through the what? Focal point. Now, if you want me to just keep saying it, please tell me. If you want me to write, you tell me so that I will know whether to write them, the 4 rules. Tell me, should I just tell you the rules or I should write them? I want to get your response quickly so that I will save your time and I'll be giving you the best method of delivery. So tell me, should I write or I should just keep explaining till I have to solve? I'm waiting for the answer. No answer yet, no response.
Yeah.
No response yet.
Yes.
Should I write these rules or I should just keep explaining? Number 1, rays.
Okay. Explain.
I should just explain.
Yeah.
All right. Number 1 rule says rays that are parallel to the principal axis, they reflect through the focal point. That is number 1. Number 2 says rays entering through the center of curvature reflect in the same direction. I repeat, ray entering through the center of curvature reflects in the same direction. That is number 2. Number 3 says that ray entering through the pole, obeys the law of reflection. This is your pole. So if you have a ray entering through your pole, it would reflect such that this angle I and this angle R are the same. So rays entering through the pole obeys the law of reflection. This is number 3. Number 4 and the last says that ray passing through the focal point reflects parallel to the principal axis. So if you have this and this is your focal point, you have a ray passing through the focal point, it would reflect parallel to the principal axis, right? So these are the 4 rules for image formation. These are the 4 rules. Is okay, right?
Yeah.
Okay. These are the 4 rules for image formation. Please do take note of these things. Take note of these things. Take note of these things. Now, these are the rules. Now, I want to look at image formation for concave mirror. Image for concave mirror. I'll still be saying it without drawing. I won't be drawing, except you want me to draw any particular one that is confusing you, then you say it. Otherwise, I'll just be explaining it. Now, I want to look at concave mirror first. Now, first one is when object is at infinity. So I'll be doing it one after the other. Now, when our object is at infinity, where will the image be formed? Image is at F. When your object is at infinity, image will be formed at the focal point. Image will be formed at the focal point. So quickly, tell me one of the properties you know for this image. I want you to be dropping answers. So this time around, I'll be asking you, it's going to be interactive. Let me just do it for this. But the next one, I would say, once I give where the object is, you begin to type. The image would have this property. It would have this, so that I will know you're following me. Now, the first one we are considering, we said when object is at infinity, image is formed at the focal point. Now, what are the properties? Point image. Image is a point image. That is to say, image is very small. Image is what? Very small. The next one you want to know is that image is real. Image is real. Very important. Image is real. If image is real, automatically image is inverted. Image is what? Inverted. You should take note that anytime you have a real image, it must be inverted. You can never have real and erect. So don't waste your time with your options. Image must be real and then inverted. If it is virtual, it must be what? Erect. So take note of this. Number 2, we want to consider when object is behind C. That is to say, when the object is placed behind the center of curvature, where will the image be formed? Image is at what? Image is between C and what? F. Image is formed between C and F. I want you to list the properties for me this time. So let's check. Who is saying it?
Okay.
Number 1 property.
Jess said it's formed between C and F.
Thank you.
Okay. Chima is still saying the same thing as between C and F.
Thank you.
Jess said that image is real.
Image is real. I love that. Image is real. Very good. Any other different
Chima
one?
said image is inverted.
Image is inverted. You are intelligent, because if this person has said it is real, and I agree, it means it must be what? Inverted. So image is inverted. Thank you. Another one. Any other person?
Jess said image is diminished.
Thank you. Image is diminished. Diminished. When you say diminished, what does it mean? Image is smaller than the object. That's what it means. Image is smaller than the object. Before we move on, when you say image is diminished, it means that magnification would always be less than 1. Take note. Magnification would always be less than 1, right? That is to say, your magnification will be something like 0.5, 0.2, 0 point something. That is what it means. Another property. Is there any other one? I think it's complete, right?
Yes.
Yes. It is real, it is inverted, it is what? Diminished, and it is formed between C and F. Now, number 3, I want to look at number 3. When object is at C. When object is at C, that is to say, the object is at the center of curvature. Now, where will the image be formed? Image is at. Any answer?
Yes.
When object is at C, image is at where?
C. By
Thank you. By who?
Roots.
Roots. Thank you. I love that. So when your object is placed at the center of curvature, your image will be formed at the same place, which is the center of curvature. Now tell me the properties. Properties. Anyone?
Yes. Just said
Who?
they are the same size.
Who?
Jess.
Okay, Jess. Thank you. They are what?
Same size.
Thank you. Image. Image is same size. Same size as object. Image and object are the same size. Number 2.
Chima James said
Chima.
image is real.
Image is real. I love that. Image is real. Thank you. And number 3.
Jess also said that magnification is 1.
Thank you. Thank you. Magnification. Magnification is what? 1. This is a common exam question, and I love the fact that you were able to dictate this. Remember, in this case, we said magnification is less than 1. But in this case, we said magnification is 1. Exam can ask you, say, where will an object be placed in front of a concave mirror so that the magnification is unity? And what is the answer? Object should be placed at the center of curvature. So I love this. Any other property?
Chima said image is inverted.
Image is inverted. Chima, thank you. Very correct. Because if image is real, then it must be what? Inverted. Then I want to point out something for you very quickly. It is under this condition that your concave mirror can behave as a plane mirror. It is what? Under this condition that your concave mirror can behave as a what? Plane mirror. So what it means, they can ask you in exam, say, where will object be placed in front of a concave mirror so that that concave mirror behaves as a plane mirror? That is the question. The object should be placed at the what? Center of curvature. Now, very quickly, we want to look at number 4. Number 4, when object is between C and what? F. I'm waiting. When object is between C and F, where will image be?
From the previous one, someone said that it is used as a shaving mirror in this condition.
Okay, but I beg to differ. So this is not where you use this as a shaving mirror. We're still going to mention that. Thank you for noting that so that I don't miss it in exam. So this condition is not actually used for shaving mirror, right? Yes, we're going to see the condition. So, and this is the reason why we don't actually use plane mirror as a shaving mirror. A plane mirror is not used as a shaving mirror. Rather, a concave mirror is used as a shaving mirror. And it is not under all conditions that a concave mirror can be used for shaving. It is one condition which we're going to mention at the end. Now, this one says when object is between C and F, image is
beyond center of curvature.
Thank you. Image is behind C. Yeah. Image is formed where? Behind C, at the back of C. Very correct. Property 1.
Okay. Winifred said image is magnified.
Winifred, image is magnified. I love that. Image is magnified. Magnified. What does it mean if you say image is magnified? It simply means that under this case, magnification is greater than 1. So it means that whenever you get magnification of 1.5, this case should be suspected. So under this case, your magnification would be 1.2, 1.5, numbers that are bigger than 1. Next.
Gege said,
who?
Gege. Image is inverted.
Image is inverted. Image is inverted. Is that true? Yes, it is.
Chukwuemeka said image is real.
Image
It's real.
is real. Thank you. And number 4. Okay, I think we're okay, right?
Yes.
Yes. Image is magnified. 1. Image is inverted, correct? Image is what? Real. So this is very good. And where is it formed? Behind the center of curvature. Now let's look at the 5th one. We have 6 of them. Let's look at the 5th one, number 5. When object is at F. When object is at F, image would be formed where? Image is who has this now?
Okay. Image
Jeff.
is,
I love that.
James.
Jess, okay.
He said that image is at infinity.
Image is at infinity. Perfect to a fault. Image is at infinity. Now, watch. This is what the exam would ask you. Exam would ask you, where will an object be placed in front of a concave mirror so that the image cannot be seen? They will not tell you infinity. They will say, where will an object be placed in front of a concave mirror so that the image cannot be seen? You are very correct. The object should be placed at what? F. Because any image that is at infinity cannot be seen. So take note of that. Give us the properties. 1.
Okay. Just again.
Jess, wow. I need to give you a gift. Jess.
Image is real.
Image is real. Do we agree? Of course, yes. Image is what? Real. Even though we cannot see it, but we know from our analysis that it will be what? Real.
She's the first person to say that image is inverted.
Image is inverted. Thank you. We can't see it, but we still know that image is what? Inverted, because it is real. Any other one?
Okay. Ruth said image is big.
Image is big. Thank you, Ruth. Image is magnified. Is magnified, right? Yes. So these are properties that you should know. Now, I believe that the way we are mentioning these things, they should just stick in your head, because if it is whether you would see these things, you would see about 5 of them in your exam, about 5 of them mixed up in your exam. So please do well to know it. It's not something to cram, it's something to understand. Now, number 6 and the last, before we now look at convex mirror, look at calculations, look at lenses very quickly. Number 6, when object is between F and P. What does P stand for? Pole. When object is between the focal point and the pole of your mirror, where will the image be formed? Image is at. First person to give me that is who? Chukwuemeka, thank you.
John Paul.
Is it the same person? Chukwuemeka, John Paul.
Yes.
Okay.
He said it's formed
behind the mirror. This is the that an image is being formed behind the mirror. Take note. We have looked at 6 cases. The first 5 cases, the images are always formed in front of the mirror. So for a concave mirror, there is only one situation where the image is formed behind the mirror, which is this. So don't mix it. So image is behind the mirror. That is to say, image is at the back of the mirror. Give me one property.
Winifred. Image is virtual.
Image is virtual. Now, if you notice, we studied number 1, 2, 3, 4, and 5. Real. So it means that the concave mirror produces virtual image for only one condition. And what is that condition? When object is between F and pole. That is when your concave mirror produces virtual image. Number 2.
Okay. Jess said.
Jess again.
It's here the mirror can be used as shaving mirror.
Powerful. So let's put it as a point to note before we call it. So let's note it now. Jess, thank you for bringing that to our notice. Now, They can ask you in exam, a concave mirror can be used as a shaving mirror. We agree. Under which condition? A concave mirror can be used as a shaving mirror. We know. Under which condition? It is under the condition where the object is between F and P. So thank you for noting that. So in this condition, the mirror is used for shaving. I love that. It means you're moving ahead of me, Jess. Thank you. The next property.
She continues and said it has high level of magnification.
It means that image is magnified, or let's use your term, image is highly magnified. Now, exam can still ask you, why is a concave mirror used as a shaving mirror? It is this answer you gave. It is because a concave mirror can produce a high level of what? Magnification. Take note of that. That is why you use it as a shaving mirror, because it can produce a high level of magnification. Now, number 3.
Chukwemeka John Paul.
John Paul.
Image is upright.
Image is upright. Thank you. Image is upright. Right? Another name for upright is what? Erect. Now you should note, exam would also say, which of the following positions of objects in a concave mirror would give us an upright image? I repeat, which of the following positions of objects in a concave mirror would give us an upright image? You would see different options, but you should know that no option should confuse you, because the correct answer is that the upright image will be formed when your object is between F and P. When your object is between what? F and P. That is the only time you can form an upright or an erect image. So we are done with this. Quickly, we want to look at image formation for convex mirror. Image formation for what? Convex mirror. Now, for convex mirror, we have only one. I have an exam question I'll ask. For convex mirror, remember for concave mirror, we had 6 different positions. But for our convex mirror, we have only one position, only one, right? Now, irrespective of where object is placed in front of your convex mirror, the image is formed behind the mirror. Take note of this. Irrespective of the position of the object in front of your convex mirror, image is formed where? Behind the mirror. So take note. If this is the case, what are the properties of this image? Now, before you list, let me give you this question so that you use it and answer. Now, this exam question says, what is the nature? Let me write it. What is the nature of the image produced by the convex mirror, irrespective of the position of the object from the mirror? This is it. Now I'll read out the options. I won't write them. Or do you want to answer without options, so that you tell me? You want to answer without options? Because I believe without option you should even know it. Okay. The question says, what is the nature of the image produced by the convex mirror, irrespective of the position of the object from the mirror? Tell me.
Okay. We have Anthony. Upright.
We have 3 things in our option. Let me give you options so that it will help you. Option A, virtual. erect and magnified. That is option A. Option B, virtual, inverted, and diminished. Option C, virtual and diminished. Option D, real, inverted, and diminished. So give us answers like this.
That's how we've gotten so far. It's virtual upright only. But
virtual upright. What about magnified? Whether diminished or magnified? I need the combination.
Then just said option C.
Option C,
yes.
Virtual, erect, and diminished.
Then Chukwuemeka said option A.
Okay. Option A is virtual, erect, and magnified.
Chima said C.
C, okay.
Then Winifred said virtual, erect, and diminished.
Oh, that's option C.
Yes. Anthony and Chidibem agreed with option C.
Okay.
Then Favor said option A.
So now, thank you. It means you are really following me, and I'm happy for you, because in your exam, you get nothing short of A. Trust me, nothing short of A with God. You'll get nothing short of A. So if you continue at this pace. Now, the correct answer is virtual, erect, and diminished. So you should know that irrespective of where object is in front of a convex mirror, the nature of that image would always be virtual. That is one. It will always be, once it is virtual, you should know it should be what? Erect. And then it is diminished. Diminished. It is diminished. So these are what you should know as the nature. Now, quickly, we mentioned that, I want you to note, we mentioned that the concave mirror can be used as a shaving mirror. Shave, right? So use it to remember. Concave, shave. So it means you can use your concave mirror as a shaving mirror. What about our convex mirror? Our convex mirror is used as a driving mirror. It is used as a what? Driving mirror. Convex, taxi. Convex, taxi. Driving what? Mirror. So we can use our convex mirror as driving mirror. Now, why can we use our convex mirror as driving mirror? We use them as driving mirror because it gives us a wide range of view. Because it gives us a what? A wide range of view. So it can see something that is wide. They can ask you in an exam, why is this used as a driving mirror? It has a wide range of view. Quickly, we want to look at calculations now, which is very important. Calculations. How many persons are present?
We have 22.
22. How many likes?
17.
17. It does not equate, so it means that about 5 persons are yet to like this video. So please, 5 of you, don't forget, just click like. Click like. It's very close to your hand. Just tap like. And some of you may not have subscribed to the channel. Please subscribe, right? Remember, we cannot finish optics today. So I don't know how many hours we have spent, but once we finish calculations, if we have more time, but I don't think we still have much time. By the time we are done with the calculation, we might just wrap up the video. But if you are really going to share these videos, it means we might still do tomorrow and look at any part you would suggest. Then we're going to look at it. So do well to hit the subscribe button if you are yet to subscribe. Like the video if you have not liked it. Do well to comment after the video. Immediately after the live ends, go back and comment on the video so that YouTube can recommend it to those that missed, so that they can also watch it, right? Thanks for always supporting this channel, Prime Concepts. Now, I want to look at calculation. I will quickly give us the formulas that we need when doing calculation. Now, remember, the formulas applies to concave and convex mirror. It applies to both of them. What are the formulas we need? Number 1 is what we know as mirror formula. Mirror formula. What is mirror formula? 1 over F equals 1 over V plus 1 over U. Never you forget this formula in your life. 1 over F equals 1 over V plus 1 over U. This is what we know as mirror formula. What does F represent? F represents focal length. Focal length. V represents image distance. Image distance. U represents object distance. So you should know this. Number 2 formula I want you to know is that focal length is actually radius of curvature over 2. So if they give you radius of curvature and you don't like to use it, you can just convert it to focal length by dividing it by 2. Number 3 formula I want you to note. Number 3 is that magnification M is given as minus V over U. This is number 3 formula I want you to note. Magnification is the ratio of image distance to that of object distance. What is the negative sign? The essence of the negative sign is from our derivation to tell whether it is virtual or real, right? Yes, if you check our YouTube channel, go to optics, you will see the derivation. So this time we are just revising for you. Now, then the fourth formula you should know is that magnification is height of image over height of object. This is number 4. So you should feel free to always equate these two formulas since they are the same. So you feel free to always say HI over HO equals minus V over U. Feel free to always know that this is your number 5 formula. So these formulas are paramount. Anything we are going to solve right now will be dependent on these 5 formulas, right? Quickly screenshot it. Tell me to move on if you are done taking note of the formula. Say move on before I move to the sign convention. Say move on. Try to be interactive just like you have always been. I love how we interacted in the image formation. So say move on. Can I rub? Any response?
Move on.
Move on. Thank you. So now, since we know formulas, one beautiful thing about Miro is that you cannot apply the formulas without knowing sign convention. So this is the secret. What I want to give now is the secret of Miro. If you know Miro, you can teach it the way I'm teaching it. If you know this sign convention, you can teach Miro the way I'm teaching it. Now, a student asked me, chatted me on WhatsApp and said, prime concept. What is the secret behind remembering a lot of formulas in physics? The way you dish out formulas in physics, how do you remember all these things without book? And I told the students that the simple secret is teaching the concept you have learned. So when you are learning a concept with the hope of teaching it, you will never forget that. You will never forget that concept. So that is the thing. So once you understand this sign convention, I promise you, you can teach to anybody. Convention. You can teach to anybody and you get it right. Now, number 1 convention we want to consider is for concave mirror. Concave mirror. For concave mirror. One of the things you need to know for concave mirror, remember, there are different, when you say sign convention, there are different conventions. So please, if you want to follow the one I will give you now, follow it. Don't mix the one I'm giving you with any other one you have known that contradicts. If the one you have known, you understand it too well, you can follow it. But the moment you mix my own and mix any other one you have learned, you will miss it. So you can choose to forget what you have learned and just learn this with me and follow it. Now, very quickly, number 1 is that U, which is object distance, is always negative. Object distance is always what? Negative. Number 2, focal length is always negative. Focal length is always what? Negative. Remember, we're dealing with concave mirror, please. Focal length is always negative. Number 3, radius of curvature is always negative also. Radius of curvature and focal length follow the same convention. So it's always negative. Number 4, if image is real, comma, V is negative. if image is virtual, comma, V is what? Positive. So these are the sign convention. Once you just put this in your head, trust me, we'll solve any question. So take note of this. Now, please, what do I want you to know when applying this sign convention? I want you to know something. You only apply this sign convention when you have a value, right? What do I mean? Say they tell you that you're dealing with a concave mirror. They say you are dealing with a concave mirror, and they told you that U is 20 cm. They tell you that V is 15 cm. They say find F. Now, if this is what the question is, before you solve, you ask yourself, for a concave mirror, U, is it always positive or negative? You will now come back and say, okay, U is always what? Negative. You quickly come to this and put minus. You come again and ask yourself, for a concave mirror, V, is it positive or negative? Then you ask for you to choose whether V is positive or negative. The question will tell you a virtual image or a real image. Let us assume that we are dealing with a virtual image. If we are dealing with a virtual image, what do you think V would be? Positive or negative? It is going to be what? Positive. So I will come and say V is positive. Now, I don't have F. I am looking for F. The mistake some of you make is that when you want to look for F, you now come to your formula, which is 1 over F equals 1 over V plus 1 over U. You now come to your formula and say, since we said F is always negative, you now come here and put minus at the back of F. The moment you do this, you have failed it. So you only use these signs when the number is given to you. If the number is not given to you, ignore it. Don't just solve. At the end of the day, your answer will carry the sign. So if I want to solve, I will just go straight and solve. I won't put minus for F. But by the time I solve, you will notice automatically your F will carry what? Minus. Now, let's try it for this and see. So I have 1 over F equals, I'm using these values, equals 1 over 15. Then this plus will change to minus because of this. So I have minus 1 over 20. Please solve this. Tell me the value of F. I'm waiting for you. Fast. Solve it. Tell me the value of F you got. I'm waiting. Check if anybody is fast enough to produce the answer. Solve it. Tell me the value of F you have.
What is happening to it? It's becoming
Blood. Is it clear? Check now.
Okay, Anthony.
Okay. Please, if the video, if it is becoming blood, just indicate. Let's know. Let's know.
Anthony says 60.
Anthony said it is 60. Is it minus you got or plus? I want to know. That is what I'm interested in.
Winifred says 60. They're not putting the sign.
Okay. Now let's verify. So we have 1 over F equals what? Our LCM for these two is what? Is 60. Right? Now 15 in 60 would go how many times? I think 3 times and 4 times. 4 times. So 4 times, this is 4 minus 20 in this would give us 3. 3 times this. So I have 4 minus 3 is 1 by 60. Right? Yes. So what do I have? For virtual, it is at the back of the mirror, which is positive. Real is in front, which is negative. So what do we have? We have this. Okay. So because this answer is being positive, right? Anyway, let's move on. Let me not waste time because I just picked this value. So maybe that is why I'm having that challenge. So but let's move on. Normally we should get negative, telling us that focal length is negative. We're dealing with a concave mirror. So maybe because I just randomly picked these values. So now let's move. Let's move. Remember, we're dealing with sign convention, and we're given the sign convention for concave mirror. What about for convex mirror? Convex mirror. Is this still blood?
Yes.
From your end.
That contain.
That's blood.
Yes.
Now it means if it is blood, we'll have to tidy up the video because we can we pause and continue again.
If you see the comment section, you see what.
Now what?
But in this video here, it's very clear.
All right. So, okay. Do you want us? I want you to just quickly respond. And do you want us to just tie it up here instead of restarting the video? And let's continue tomorrow. Right? I think it will be okay for us to continue tomorrow instead of restarting it. Just comment which one is best so that we'll know if we should restart it now or we should just continue to put it over to tomorrow and continue. I'm waiting for your response so that we can decide on what to do next. Just type which. Should I end it because of this condition of blurriness, or we should continue tomorrow?
That is okay now.
Remember the battery. Power bank. I don't know. How many percent?
It's 13.
Is it okay now?
So
They're saying it's okay.
Yeah. They're saying that it's okay. Maybe it's network.
Okay.
It's clear now. It's network.
Okay.
Let's continue. It's okay now, sir. No, sir. Continue now.
Okay.
Some say we start today, sir.
Okay.
Some
means
say
we'll continue.
tidy off and end. Some say start. Let's continue. No, move on. It's network.
Okay. Okay. Let me move on because we're almost done.
Yeah.
So, it's how many percent? All right. For our convex mirror, the sign convention quickly, U is always negative also. Just like for concave, U is always negative. Number 2, F is always positive. This is now the difference. F is always positive. Number 3, R is always positive also. And then number 4, V is always positive. V is always positive. What it means, if V is always positive, it simply means that for your convex mirror, image is always virtual. Image is always what? Virtual. So this sign convention, screenshot it. We want to get to the first question now. Number 1. A man stands 50 cm from a concave mirror, with radius of curvature 10 cm. Find the position of the image and the magnification. I'm giving you 30 seconds to solve. Remember, you are preparing for exam, so solve it. 30 seconds. Let me refill my marker. Is it clear from your end?
Yeah.
It's dry.
Yes.
Okay.
That's it.
Any answer?
No.
Nothing. All right, I will solve. I've refilled my marker and I gave you enough time to solve. So I'll solve because this is a revision class. Now, quickly, Winifred.
Minus 5.56.
For which one?
No, not specified.
Minus 5.56 cm, I guess. All right, let me solve. A man stands 50 cm from a concave mirror. First, I'm dealing with a concave mirror. Remember, the man is the object. So the man stands 50 cm. It means that the object distance is 50 cm. So object distance U is 50 cm. Since we are dealing with a concave mirror, is U going to be negative or positive? It should be what? Negative. You are very correct. With radius of curvature 10 cm. So it means R is 10 cm. Please tell me, should R be negative or positive? You are correct. R should be what? Negative. But I want to change this R to F. F is actually R over 2. And what is my R? Minus 10 by 2. So my F is going to be minus 5 cm. The question says, find the position of the image. Please take note. Position means distance. Size means height. Position means distance. So find position of the image. It means we're finding image distance V. Position of the image and magnification. So quickly I would use my mirror formula. 1 by F is 1 by V plus 1 by U. So I have 1 by minus 5 equals 1 by V. Then this plus will become minus. Take note of it. So I would say minus 1 by 50. So I want to rub this. What will this give me? This is going to be minus 1 by 5. When this one crosses, because this is minus, when it crosses, it will now become plus 1 by 50 equals 1 by V is left here. Now, what is my LCM? My LCM is 50. 5 in 50 is 10. 10 times minus 1 is minus 10. 50 in 50 is 1. 1 times this is plus 1 equals 1 by V. So I have minus 10 plus 1 is minus 9 by 50 equals 1 by V. Now, since 1 by V is minus 9 by 50, it means that V is minus 50 by 9. Give me the answer.
Minus 5.56.
Minus 5.56 cm. So somebody got it, which I just rubbed. Who is that person?
Winifred.
Winifred, congratulations. Thank you. So our image position is, now you will not see minus in your option. I have options here. I have the options here. Option A, I have 5.56 centimeter. Then 0.11 as the magnification. Option B, I have 6.65 centimeter, comma, 0.12 as magnification. Option C, I have 7.55 centimeter, comma, 0.13 magnification. Option D, I have 7.80 cm and then 0.14 magnification. With this kind of options, I don't need to solve for magnification. I'll pick option A, right? Because that is the only option that I have 5.56. Assuming any other option has 5.56, that is when I'll solve for magnification. But since no other option has it, it means that the magnification should be 0.11. We're going to verify. Now, what does it mean? Like I said, you will not see minus in your option. This minus just describes the nature of the image. Now, when you have minus, what does it mean? It means that the image is actually real. So what you would see is 5.56 centimeter, comma, real. The image is real. Now, want to find the magnification. Magnification N is minus V over U. which is minus, what is our V? Our V is minus 5.56 divided by my U. What is my U? Minus 50. So if I punch this, I'll get punch for me.
0.11.
Remember, there will be a minus in my answer, right?
Minus 0.11.
Minus 0.11. But will I see minus in my option? Of course not. What does this minus tell you? Whenever you see minus in magnification, it means that the image is inverted. The image is what? Inverted. That is what it means. So this is actually 0.11 inverted. If it is positive answer, it means that the image is what? Erect. Negative answer means it is what? Inverted. I will take one more question and we'll draw it to an end in this video. So one question and you are the one to solve it. So I will allow you to copy this or screenshot it fast. So all right, I think I can rub this. This is the last question for today. So it means we should continue tomorrow since your exam is on Monday and Tuesday. An object An object 5 cm high is placed 20 cm in front of a concave mirror so that it produces an image 60 cm from the mirror. Full stop. Find the height of this image. I'm giving you 30 seconds to solve this. 30 seconds to solve this. 30 seconds to solve this. Then we want to tidy up. This will be the end. I'll point out one thing, and that is the end of this video. Then we're going to conclude if we should meet tomorrow.
Charles Igor has said 15 cm.
Charles, let me see if I have options. I love that. 15.
Yeah.
15. 15 is in my option. Thank you.
Winifred
15 cm. Who else?
Winifred
agrees. Thank you.
22.
Oh, okay. I would solve this very fast. An object 5 cm high. It means the height of the object. So the height of the object is 5 centimeters. Is placed 20 cm in front of the concave mirror. So it means that the object distance U is 20 cm in front of the concave mirror so that it produces an image 60 cm from the mirror. The image distance, the image is 60 cm from the mirror. So image distance V is 60 cm. Find the height of the image. So we're looking for HI. Now, before you solve, once you have listed these things like this, the next thing you want to do is to apply your sign convention. Now, we know that we are dealing with a concave mirror, and for concave mirror, the object distance should always be what? Negative. So let's read it again. An object 5 cm high is placed 20 cm in front of a concave mirror so that it produces an image 60 cm in front of the mirror. Now watch. Whenever image is formed in front of the mirror, image is real. Whenever image is formed in front of the mirror, image is what? Real. And remember, when image is real, image distance is negative. So I'll put minus here. So you can see how exam would come. So that the image is formed in front of the mirror, which means that the image is real and image distance is negative. If image is formed at the back of the mirror, image is virtual, image distance is positive. Now let's solve this. we know that HI over HO equals minus V over U. So HI is going to be minus V times HO over U. So I have minus 5, right? Then U is what? U is minus 20. So if you solve this, you get
15
H to be what?
15 cm.
HI is 15 cm. Perfect to a fault. Negative, right?
No.
It's negative.
Okay, yes.
Yeah, negative. So meaning that it is what? Inverted. It is what? Inverted. That is why the negative is there. But will you see negative in your option? Of course not. The negative sign just tells you it is inverted. Finally, there's something known as spherical aberration. Spherical aberration. Why am I pointing it out? That is the end of mirror.
So please differentiate for them the U and V. Which one is object and which one is image?
Okay, that's what they're asking.
Yes.
The object distance is 20.
That's what it means. U, what is
okay. Now, if I have a mirror like this is a mirror. I think you are asking, some of you are asking, I should differentiate between object distance and image distance. If I have a mirror like this, and you call this to be your object distance simply means the distance from here to the mirror. Object distance is always the distance from where your object is. If I'm standing in front of this camera now, I am the object. It means that the object distance is going to be the distance from me to the camera. That's object distance, right? Yes. Now, object distance is the distance from this image to the mirror, not to the distance from the object to the mirror. That is object distance. So this is U. While the height, this height is what you call height of object. The height, how tall it is. Then if your image is formed, let's say this is where your image is formed, for example, this image distance is the distance from your image to the mirror. That is image distance, and it is called V. I believe that this thing is clear to you now. While the height of this image is what you know as image height. So I hope it is clear now. All right. Now I'm talking about spherical aberration. Spherical aberration. Spherical aberration. I think it should be double B if I am correct. Spherical aberration. What is spherical aberration? Spherical aberration is a phenomenon where all the parallel rays do not converge at the focal point. Spherical aberration is a condition, or you can say it's a phenomenon. I will choose to say it's a condition where all incident parallel rays do not converge at the focal point. Now, if you have, this is your concave mirror, and then you have parallel rays like this, normally, when you draw parallel rays, they are supposed to converge at the focal point, like this. But in a practical case, those rays that are far from your principal axis, like these ones, they don't converge. These ones will come like this. They don't converge at this point. This one would also come. The only ones that converge at the focal point are the rays that are close to your principal axis. Remember, rays that are close to your principal axis are called paraxial rays, while those ones that are far are called marginal rays. So spherical aberration is a condition where marginal rays do not converge at the focal point, but paraxial rays converge at the focal point. So what it means is that if you have a condition of spherical aberration, the image would not be clear. Because if your image should be clear, it means that all the rays should converge at your focal point. So one implication of spherical aberration is that your image would not be clear. The light would not be bright at that point. Aberration means disorder, right? Now, very quickly, what would the exam ask you? How do you correct spherical aberration? Spherical aberration can be corrected using, instead of using spherical mirrors for reflection, you use parabolic mirrors. Spherical aberration can be corrected using what? Parabolic mirrors. So that is to say, you want to do reflections with curved mirrors. Instead of choosing, remember, spherical mirror is a type of curved mirror. Parabolic mirror is also a type of curved mirror. So instead of you using spherical mirror, which is your concave mirror, you prefer to use parabolic mirror. Parabolic mirrors are mirrors that have the shape of a parabola. You know, a parabola is more curved than your concave mirror. This is how it is. It's more curved. So that is how you can correct spherical aberration. So at this point, I'm drawing the curtain to this video. I want to appreciate all those that participated, irrespective of the network challenge. Some of you were consistent from the start to this point. Such people include Anthony, Jess, I appreciate you, Jess.
Chike Chisom,
Chima James,
Chukwuemeka
John Paul, always consistent.
Ruth,
thank you.
Winifred,
thank you.
Iba
Chidimma.
Gege University.
Gege University on my channel. All right.
Favor Iroma. Zebelum
Enoch, thank you.
Jikeme Dubem. Innocent.
Henry. Charles. David. Thank you. I really appreciate you, and trust me, you are going to make A in this course, and you would send me your testimonies on my WhatsApp. Remember, this is Prime Concept. I'm going to drop on my WhatsApp platform. We're going to decide if we're going to have this class tomorrow, and we're going to decide what time it would be. So I will drop a poll on our WhatsApp platform. Then you tell me which of them you want. But as it may be at this point, we have come to the end of this video. If you have followed till this point and you are yet to subscribe, please immediately after this, you hit the subscribe button, you drop your like, comment after the live session. You just drop a comment, say thank you for the video, then forward it to your class group. Thanks for watching. This is Prime Concept. Test.